I recently watched Dr. Dennett's video of his theory of free will within a deterministic natural universe. At first I was intrigued and thought this was a very good way of describing how I experience reality, but something bugged me about it. This then is my critique of his deterministic theory of free will. First, we will review a classical understanding of the deterministic view of the universe, which should give us a determined future. So let's see how well determinism can fit our view of reality. We will take the Shoemaker-Levy event as our static snapshot. If we know the speed and direction of Jupiter and the comet, we should be able to compare the accuracy of our prediction with the observed unfolding of events as they occurred. So when Shoemaker-Levy hit Jupiter, our model held up with great accuracy. Of course, we do this all the time and have had much success modeling our world and universe based on this causal theory. It would follow then that given the right computer algorithms and sufficient computing power and an accurate static picture of the universe at any time along the time axis, we should be able to recreate the past and predict the future. Thus, our classical deterministic view of the universe would seem complete, except for when it comes to people. Because as much as we would like to believe determinism could explain Mother Teresa better than Mother Teresa can explain Mother Teresa, we know that classical determinism breaks down, but we don't know why. And perhaps it should, because if this was predetermined, then so is this. If it's true for them, it would be for each of us, and this does not reflect our experience of reality. Nor would we expect to ever see a computer capable of predicting our future beyond the point at which choices can be made. So what can Dennett do to resolve our experiences of determinism of free will? Thus comes the duck-brick theory. It's at this point in the video that Dennett goes out of his way to show that we cannot change the future. It's an inherent ability in us to anticipate the future, and thereby we make figmentations of possible futures that are not really there. There is a future coming at us. It's inevitable. It's just coming. We think there's different futures to choose from because we anticipate and create figments that we throw forward, but they're not really there. It's an illusion, and that's what he's going out of his way here to show. And so therefore the future, changing or not, is not based on choice. It's based on you can't change it anyway. So that's what he's going out of his way here to say. So if we can get that flaw out of our thinking, he believes then by definition we will understand that the future is out of reach. It's just not there. It's it's going to happen and capable of being changed. So whether a choice is made or not, the future just simply is whatever the future is. So therefore we can assume that determinism does not change the future any more than free choice does. And we'll use this example below now just to show how this plays out. So now in this model, our intended victim presents a new variable because, unlike Jupiter, he has evolved the ability to calculate the anticipated future of this scenario. He is capable of taking avoidance measures based on as many possible choices that he can be calculated and acted upon. So the future is still the future, but the victim is capable of making choices within the epistemic horizon, and I have no idea what that is. So free choices can be made in a causal-only universe. But I want to look at something else. So what I'd like to do here is keep the same scenario but lose some of the extra baggage. You notice when Shoemaker-Levy was hitting for Jupiter, nobody was in a big panic to rush to NASA and say, somebody phone Jupiter, let Jupiter know it's going to get hit by a comet. Simply because there was no humans involved there. Nothing that we perceive would get hurt. Nothing we could do. It was natural order. But in Dennett's observation of the brick duck throw, we see a person going to be hit, we feel like we got a call out. I think if we change this scenario here, we can take some of that extra baggage out of it. And I'd like to see and show it as the exact same example. So Dennett makes no bones about us being a biochemical computer, so I'll take a page from Dawkins, who sees Dennett as a mentor, and I'll simplify the problem this way. So without all this emotional baggage now, we can see that this rocket ship is autonomous with a radar and that for, watching out for rocks and stuff, and basic enough computing skills to avoid the asteroid. correct its course, and continue on its way to its future. And essentially, this machine, it is capable of recognizing a problem, anticipating and weighing possible futures, and can even act to avoid what our static picture here tells us must happen. Now, I think it's more obvious now, but can we not simulate this on a computer, even the simple ones we have now? I mean, my kids play all kinds of space games, and I see them doing this all the time. It can be easily simulated. But this is the exact same scenario as the brick duck throw, just less complex. Here, with the human face, it is more obvious that we can predict the future as easily as the Shoemaker-Levy event. So what happened? Where did our logic fall down? I think he may have left something out. Time. It takes time for even our best computers to do the calculations. How long does it take? 1 second? A tenth of a second? 1/100th of a second? While anticipating the future, his static picture has to change at least one Planck length unit and one Planck time unit for each micropart of the calculations that he's making. It doesn't matter if the biomech computer is calculating one anticipated future or simultaneously X possible anticipated futures. It must do so before our static snapshot changes the next Planck instant. So in order for the brick duck model to work, Dennett must ask us to suspend the laws of nature, time and motion, while he works out the possible anticipated futures. Other than that, as each calculation is made, weighed, and eventually chosen, it recedes into the past and becomes part of the new static picture we must work from. In this way, as our rocket ship scenario shows us, the whole process is still classically determined. I had a few other side thoughts, of course. I said, well, maybe what's more important is not the fact that we can calculate the future, but that more than one choice can be offered. That was true back when we couldn't see past the epistemic horizon, which I think I finally figured out what it is. It's the extent to which we cannot gain further knowledge until current choices are made. But our new model with the rocket ship shows that we can predict on into the future, and there is no epistemic horizon. So then again, since time moves forward, I figured at the speed of light, maybe our computers can calculate faster than that, because nothing moves faster than light. So shouldn't this create a knowledge horizon? And then I said no. Knowing that I can already accurately predict the Shoemaker-Levy event, and that the brick duck event is the same, I should also be able to accurately predict Shoemaker and Levy. So now we've come full circle and are faced with our ugly initial predicament. A totally causal understanding of the universe leaves us with a classical deterministic future. With powerful enough computers, we should someday be able to rent a DVD of our lives and sit at home and watch ourselves sit at home. In fact, with quantum computers on the horizon, they may be able to predict our futures while we could not predict theirs. So thus the computers will become more human than we believed we were. And I don't think that's possible.